Hello, this is Tony Heller from RealClimateScience.com, setting the record straight about climate. I was hiking on the Appalachian Trail in Virginia a couple of weeks ago. After the hike, I met up with a rising star in the weather and climate community, a high school junior named Chris Martz. We were talking about Venus, and Chris asked me to make a video about what we were discussing. I like the idea of doing videos with real science rather than just debunking the junk science of climate alarmists. I used to be a high school science teacher and really enjoyed doing that. The only reason I quit being a teacher was because it didn't pay well enough to make a living. Venus was the Roman goddess of love. This painting was made by Botticelli around the year 1480. The planet Venus was named after the goddess. Venus is the third brightest object in the sky after the sun and the moon. The reason Venus is so bright is because it's completely surrounded by clouds. These white clouds allow little sunlight through its atmosphere and reflect most of the sunlight back into space. Thus, Venus appears very bright in the sky. What you're seeing when you look at it is reflected sunlight off the clouds. Venus is about the same size as Earth, but as you can see, there's some major differences. Venus has a lot more clouds than Earth does, and most of Earth's surface is covered with oceans. You can't see it in the picture because of the clouds, but there's no liquid water on Venus. And there's a couple more things which you can't see from these pictures. Venus has a very thick atmosphere with a surface atmospheric pressure about 90 times higher than our planet. Venus is also extremely hot. Temperatures there are hot enough to melt lead. You can see from this drawing that Venus is just slightly smaller than the size of the Earth. Amazingly, the Russians were able to land a spaceship on Venus in 1982 and take a few pictures before the electronics fell apart. As you can see, Venus looks a lot like Arizona. So let's go to Arizona for the next part of our lesson. I've hiked down the Grand Canyon on days when it was very cold and snowy at the top, and by the time I got down here to the plateau, it was extremely hot. The bottom of the Grand Canyon is always much warmer than the top. Temperatures increase about 5.5 degrees Fahrenheit for every 1,000 feet you go down in elevation. The Grand Canyon is more than 5,000 feet deep, so temperatures at the bottom are about 30 degrees Fahrenheit warmer than temperatures at the top. The more weight of air there is above you, the higher the temperatures are going to be. The atmosphere on Venus is about 90 times thicker than the atmosphere on Earth. Thus, the surface of Venus is extremely hot for the same reason why the bottom of the Grand Canyon is hot. If the Grand Canyon was another 20 miles deeper than it is, it would be just as hot down there as the surface of Venus. So this begs the question, why is the atmosphere of Venus so much thicker than the atmosphere of Earth? So we're going to go back to the Grand Canyon to answer that question and do some geology. You can see that the Grand Canyon is made up of distinct layers of different colored rock. Some layers are white and some layers are more reddish. Some layers form steep cliffs and other layers make more gentle slopes. These sort of properties are determined by the composition of the rocks. There's two layers we're going to focus on. One is this white layer at the top called the Kaibab limestone, and the other one is this red layer in the middle called the Redwall limestone. Let's take a closer look first at the Kaibab limestone. It was deposited in the ocean about 270 million years ago and is full of lots of fossils. There are lots of shellfish and coral fossils in the Kaibab limestone. The Redwall limestone is older. It's about 340 million years old, and it contains lots of fossils like this trilobite. This is another fossil from the Redwall limestone. This picture is the Guadalupe Mountains in West Texas, which is another 270 million year old limestone formation. It's an ancient coral reef which is thousands of feet thick. As sea levels rose, the coral reef grew with it. This is something which climate alarmists don't understand. Coral reefs adjust to whatever the current sea level is. Earth's sea level has always been moving up and down for as long as there's been oceans on the Earth. Yet coral reefs have thrived and prospered despite changes in sea level, changes in temperature, and changes in atmospheric carbon dioxide. The greatest explosion of life on Earth occurred in the oceans 540 million years ago, when CO2 levels were 15 times higher than now. Earth's geologic history tells us that life thrives at high levels of carbon dioxide. It also tells us that ocean acidification is not a real problem. If ocean acidification was real, there not only wouldn't have been an explosion of life 540 million years ago, but oceans also would have been largely devoid of life at those high CO2 levels. Now let's go back to talking about limestone, which includes coral reefs. Remember that some limestones like this one in Texas are made up largely of coral. Let's look at the chemistry of limestone. It is calcium carbonate. Note that word carbon, which terrifies climate alarmists. Limestones, including coral reefs, are made up largely of carbon dioxide. Corals and all other life forms on Earth cannot exist without carbon dioxide. Limestones are derived from a mixture of calcium and carbon dioxide. The calcium comes primarily from volcanic rock on the ocean floor, which is being dissolved by the seawater. The carbon dioxide comes from the atmosphere and also dissolves in the ocean. Corals and shellfish incorporate the calcium and the carbon dioxide to form the hard parts of their bodies. So the formation of limestones removes carbon dioxide from the atmosphere. We have very thick limestone layers on Earth which have removed huge amounts of carbon dioxide from the atmosphere. If it weren't for these limestone deposits, Earth's atmosphere would be very thick like that on Venus, and Earth would be extremely hot just like Venus's. Without the limestones, our atmosphere would be something like 95% carbon dioxide, just like the atmospheres of Venus and Mars. And remember that these limestones form in the ocean. Many limestones consist primarily of corals and shellfish. So the reason that we don't have a thick atmosphere like Venus is because we have all of these oceans. Corals and shellfish grew in the oceans, they removed carbon dioxide from the atmosphere, greatly reduced the thickness of Earth's atmosphere, and thus made Earth much cooler than Venus's. So the next time you see a coral or a shellfish, you can thank them for saving the Earth from becoming like Venus. And that's your geology lesson for the day. Prior to the time when climate modelers hijacked the name, geologists and paleontologists were always considered the climate scientists. The difference being that geologists and paleontologists actually have to know something about Earth's climate history. And unlike climate modelers, we actually have to be right a significant percentage of the time. Visit Toto on the web at realclimatescience.com. He's been pulling back the curtain on junk science and propaganda for a long time.